will discuss about one-way multivariate analysis of covariance, that is one-way MANCOVA. So this is our outline. There are 4 agenda points. What is MANCOVA? Types of MANCOVA. What are the assumptions of MANCOVA? And we'll consider an example for one-way MANCOVA. So what exactly MANCOVA is? MANCOVA removes the effects of one or more covariates from the model. This allows the researcher to see the true effect of independent variable or variables on dependent variables without unwanted interference. So there will be the covariate or the covariates in case of MANCOVA. So what is one-way MANCOVA? So in one-way MANCOVA, MANCOVA is an extension of one-way ANCOVA with 2 or more independent variables. So in one-way ANCOVA, what we have seen, there is one independent variable, one covariate and one dependent variable. So but in case of MANCOVA, there will be one independent variable that will be categorical, one covariate that will be continuous, and 2 or more dependent variables. So that's why we are saying one-way MANCOVA is an extension of one-way ANCOVA. So what are the assumptions in one-way MANCOVA? The number one is 2 or more dependent variables should be measured at interval or ratio level. That is, they are continuous. Independent variable should consist of 2 or more categorical or independent groups. So the independent variable should have 2 or more levels. Covariate should be measured at the interval or ratio scale, and there should have independence of observation in the data, and there should be adequate sample size. The sample size should be large, that will give the more robust result. And one of the assumptions that the number of observation in each group, each level of the independent variable should be greater or equal to 20. The next is there should not be univariate or multivariate outliers in the data. So univariate will be checked by box plot and multivariate outliers will be checked by Mahalanobis distance. Now there should be multivariate normality of dependent variables. So it is difficult to find multivariate normality, so we will check univariate normality of the dependent variable, and we will find the Shapiro-Wills significant value. If it is greater than 0.05, then we can say that the data is normally distributed. The next is there is a linear relationship between each pair of dependent variables for each group of independent variables. So we will see it through our scatter plot. And then second also it is saying there should be a linear relationship between the covariate and each dependent variable with each group of the independent variable. This also will check through the scatter plot. Now the next is saying homogeneity of regression slopes. So what exactly it is? The B coefficients for the covariate must be equal among all subpopulation or all the levels. How we will check it? We will find out the interaction effect of independent variable, means the factor variable and covariate, and their significant value should be greater than 0.05. If it is greater than 0.05, the significant value is, then we can say that the homogeneity of regression slopes condition holds. Then the next is there is homogeneity of variance covariance matrix. So in this case we will check through box M test of equality of covariance. Here the p value should be greater than 0.05. Now the last one is there should not be multicollinearity among the dependent variables. So the dependent variables should not be highly correlated. Dependent variables to be moderately correlated with each other. So these are the assumptions of one-way MANCOVA. Now we are considering one topic, a study of income category on both customer satisfaction and customer loyalty using covariate price. So here our independent variable is income category, dependent variables are customer satisfaction and customer loyalty, and covariate is price. So you can see here independent variable, categorical income category, 1 we are representing, that is equal to less than 25,000 income, 2 is equal to 26,000 to 35,000, and 3 is equal to more than 36,000. And covariate is price, the data is in continuous scale. Then dependent variables, 2 dependent variables, customer satisfaction and customer loyalty. For the customer satisfaction, 1 is equal to very much dissatisfied, 10 is equal to very much satisfied. Customer loyalty, 1 is equal to highly disloyal and 10 is equal to highly loyal. And the number between 1 and 10, they have the appropriate meaning. Now what are our objectives? So our first objective is to study income category, price of the product, customer satisfaction and customer loyalty of the respondents. Second, to study of income category on both customer satisfaction and customer loyalty using price as covariate. So here we will control the covariate price. Now on the basis of the objectives we have formulated our hypothesis. Our first null hypothesis is H naught. There is no significant difference of income category on both customer satisfaction and customer loyalty with covariate price. So we are saying that if we are controlling the variable price, then there is no effect of income category on customer satisfaction and customer loyalty both. Then alternative hypothesis H1, there is a significant difference of income category on both customer satisfaction and customer loyalty with covariate price. So here in the alternative hypothesis there is a difference. So our alternative hypothesis and null hypothesis. Now we have our data with us for one-way MANCOVA. Now directly we will go to our data. You can see here this is our data. The first independent variable factor is income category. It has three levels: 1, 2 and 3. This is the price of the product. This is customer satisfaction and then customer loyalty. Why these values are in decimal points? Why it is so? Because the customer satisfaction is a parameter. Under that there are many questions are there. So respondents have given the responses on these parameters and we have taken the average value of that. So that's why you can see here we do not have the exact value. Our values are in points also. So because the problem is because of the average value. So that's why it is here. So the data of these two variables, customer satisfaction and customer loyalty, they are in interval scale. Price, it is in ratio scale, and income category, it is in nominal scale. So now we'll go to variable view. In variable view, we'll first define our income category. So 1 is equal to, we are saying less than 25,000. 2 is equal to 26,000 to 35,000. Then 3 is equal to more than 35,000. More than 35,000, or you can say that more than 36,000. 36,000 and above. So it is, we can say that 36,000 and above. 36,000 and above. This is our P. Okay. Then price, it is in ratio scale. So this is nominal. Again we will do it scale because price is in ratio. Then customer satisfaction, again it is scale. These are in interval scale. So now we'll go to data view. Now we'll first see our assumptions of one-way MANCOVA. So in one-way MANCOVA, first we have to see our normality, outliers and all these things. So first we will go to analyze, and analyze we will go to descriptive statistics. In descriptive statistics we will go to explore, and we will take these two variables, customer satisfaction and customer loyalty, into this dependent list and income category into factor list, because we want to see at each level of the independent variable the data should be normally distributed. So we'll go to here, outliers also we can check. So we'll see the outliers also. Then plots, we'll remove this stem and leaf. We'll click here histogram and then normality plots with paste and then continue and then OK. So our output will come. Yeah, this is our output. You can see here. So directly we'll go to test of normality. So you can see here our data is test of normality. So for customer satisfaction at all level, that is the less than or equal to 25,000, you can see here 26,000 to 35,000, 36,000 and above. So all these significant values are greater than 0.05. Here also for customer loyalty also you can see here all these significant values are greater than 0.05. So the dependent variables at all level of the independent variables, the data is normally distributed. So that one assumptions we have proved. Now for the outliers we can go to box plot. So you can see here box plot for this income category. All these data are within maximum minimum value Q1, Q2 and Q3 within the box plot. There are no points outside this box plot for this customer satisfaction. Similarly, we can go for customer loyalty also. We can see here, you can see for customer loyalty no outlier, No outliers are there. Okay, all the points are within these box plots only. So no outliers. Now this is, we have checked the no outliers are there and the normality distributed. Then we'll see our, we have seen the univariate outliers, we will see the multivariate outliers. For that, what we have to do, we'll go to analyze and we'll go to regression and then linear, and then we'll put these dependent variables into independents and our income category on the dependent list. Okay, and then we'll go to save and then we'll click here Mahalanobis distance. Okay, and then continue and okay, and then we'll go directly to this residual statistics. You can see here residual statistics, and the Mahalanobis distance, the maximum value you can see here is 7.877. The critical value of Mahalanobis distance for two dependent variable is 13.82. It is within that limit, it is less than that, so we do not have multivariate outliers. So that assumptions also fulfilled. Okay, now you can see here this data we have got Mahalanobis distance. Now we will clear this. So there are no univariate outliers, there are no multivariate outliers. The data is normally distributed at all level of independent variables, that we have done. Then we will see the linearity. For linearity we will go to graphs, then in graphs we will go to legacy dialogues and then scatter dot, and then we will matrix and then define. Now both the variable customer satisfaction and customer loyalty, it will go to this matrix and then income category will come on the rows. So and then okay. So you can see here this is the data we have received. More or less the data is all the 6 data are, you can see here pair of data 1 2 3 4 6, all the 6 data is normally distributed. Once again, so you can click here, so you will find out all these data is normally distributed, not exactly normally distributed, but more or less the data is normally distributed. So that assumptions also fulfilled. You can do it with covariate also. Then we again will go to the scatter plot, again define, will bring our price also, and then okay. So this is our new data, you can see here. You'll see, click it again this. So all the data are, you can see here, normally distributed. Some of the violation is there, but more or less the data is normally distributed, so we can consider that. It is very difficult to find out that all these aspects you can, all the assumptions you can prove. So we have seen the normality, linearity also. Normality, linearity, outliers we have seen, and then we'll see the relationship multicollinearity. For multicollinearity we will go to bivariate, multicollinearity of the dependent variable. So we'll take these two values into dependent list. So what is our assumptions? That the dependent variable should not be highly correlated. So we okay. So you can see here the customer loyalty and customer satisfaction 0.321. So they are weak relationship between these two dependent variables. So they are not highly correlated. So this assumption also satisfied. Okay. Now homogeneity of regression slope. That, so the interaction effect of covariate and the independent variable significant value should be greater than 0.05. For that we have to go to analyze, and then we will go to general linear model, and then we will go to multivariate. In multivariate we will take these two values, customer satisfaction and customer loyalty, into dependent list, income category into fixed factor, and price into covariate. Okay, and we will see here in the model we will not do the full factorial, we will do the custom, and in custom we want to find out the interaction effect of income category and price. So we'll click it here and then we'll take it to the right direction, and we'll find out what is the significant value of that. Okay. Okay. So you can see here what is the significant value between test between the subjects effects. So interact income category and price. Customer satisfaction 0.061 with customer satisfaction 0.061. So it is greater than 0.05. Again customer loyalty 0.77. It is greater than 0.05. So this homogeneity of regression slopes condition also holds. So this is another assumption we had. So that also satisfies. Now, before we'll go to one-way MANCOVA, we'll do one-way MANOVA and we'll find out without controlling the covariate. So we'll go to general linear model and then multivariate analysis. We will remove this for some time. That is, now we are not considering this price as a covariate. We are just finding one-way MANOVA. So what will be the result that we have to see? What will be the result? This is a custom, not it is a full factorial. Continue and then OK. We just want to check what is going to happen in case of one-way MANOVA. So you can see here in most of the cases income category, Pillai trace, Wills lambda, Hotling trace and Roy's largest root. So all the threes, Pillai, Wills and Hotling, the significant values are greater than 0.05. Means it is not significant. It is not significant. If we are not considering the covariate price, means we are not controlling price, then income category has no significant effect on your customer satisfaction and customer loyalty. Now, which type of test we have to see? Normally, we consider, most of the researchers say that we have to consider Wills lambda. This is the most popular multivariate test we consider when we use MANOVA. So, Wills lambda. If all your assumptions are satisfying, then you can consider Wills lambda. If your assumptions are not satisfying some of the assumptions, then you can take the Pillai trace. So in both the cases, you can see here that it is greater than 0.05. Some of the researchers says that if the box M test is not satisfied, that is your box M test significant value is less than 0.05 and the groups are similar in size, all the levels of groups are similar in size, then you can say Wills lambda. And some of the researchers said if your groups are not equal, means the sample size of each level of independent variables are not equal, but the box sum test is satisfied, is it greater than 0.05, then you can consider the Pillai trace. So there are many thoughts on that in these aspects. So normally we consider both these two, that is the Pillai trace either or the Wills lambda, but in both the cases we are seeing here it is greater than 0.05. So we can reach to a conclusion that if we are not controlling the price, then income category has no effect on customer satisfaction and customer loyalty. This is the thing. But if you will see here individually, you can see here. So what it is saying, income category and customer satisfaction significant value is greater than 0.05. So insignificant it is, but with income category customer loyalty it is significant. It is significant. Okay. So this is the another aspect you can see here. But when we are seeing the overall together jointly both the dependent variables, then it is insignificant. Only the Roy's largest root is saying it is significant. Okay, so that you must remember this data. So it is insignificant we are talking about. Now we'll go for MANCOVA. So we'll analyze general linear model, multivariate, and then now we'll bring this covariate here. Covariate model, it will be a full factorial model. Then contrast, no need to do anything. In plots, we can take it in the horizontal axis, add it, continue, save, nothing, then we'll go to directly options. In options, descriptive statistics, estimates of effect side, homogeneity test, and we can take this income category on the right hand side, compare main effects, and then continue. Okay. So this is our output. So you can see here. So income category 1 representing less than or equal to 25,000, 10 people are there. So this is the sample size. For 26,000 to 35,000 again 10, 36,000 and above you can see 10. So these are the mean values 5, 4, 3, 8, 4 and this for the customer loyalty. So these are the mean values of less than or equal to 25,000, 26,000 to 35,000, 36,000 and above. The standard deviation, and these are the sample size. Now you can see here box test of equality of variance matrix. Here the assumption is not satisfying. It is saying that the significant value is less than 0.05. It means the variance and covariance of the dependent variables at each level are not equal, that is they are heterogeneous in nature, they are not homogeneous. So if we see like this, if our sample size are equal and then if the groups are heterogeneous in nature, then we see the Wills lambda value. So when we will go to the output, we will see the Wills lambda value. So you can see here for all the values, or in this you can see all the values, Pillai trace, Wills lambda, Hotling, Roy's largest root, all these values are less than 0.05. Less than 0.05. It means that if we are controlling our price is a covariate, we are controlling price, then income has effect on customer satisfaction and customer loyalty, because all these values are significant. Here you can see here the partial eta squared value are also 16.9, 17.6, 0.82, and all these values are there. So this is the thing you can see here. So it is significant. If we are not controlling price, then it is insignificant. If we are controlling price, then it is significant. If we go down, you can see here price, income category. If we are controlling price, customer satisfaction, you can see here it is insignificant. For customer loyalty, it is significant. But when we are bringing it together, both are significant. When we are considering both these two and we are controlling this price, then both are significant. We have seen in the lambda value, these are the comparison you can see here. Income category, customer satisfaction, all are most of the values. Income category 25,000 to this value, insignificant, this is insignificant, and the 25,000 and 36,000 and above, it is, you can see here significant values there. There is a difference. Okay, so this is the data. If we will do the individual comparison, again you can see here in the graph itself, for less than or equal to 25,000, it is 5.10. For it is 26 to 35,000 is 3.9, and again it is 36,000 above, again it is less. So these are the values you can see here, mean values. Now how to report this data? How to report? You have seen this, all these values are significant if we are controlling our covariate price. All are significant. What does it mean? Means income category has effect on customer satisfaction and customer loyalty. Now how will report this data? I will report this data. You can see here. This is our data. So the data collected for analysis holds all the assumptions of one-way MANCOVA. So the significant values of multivariate test of Pillai trace, Wills lambda, Hotling trace, and Roy's largest roots are less than 0.05. So it has sufficient evidence as per the decision rule to reject the null hypothesis. Hence H1, that is alternative hypothesis, is accepted. What does it mean? There is a significant difference of income category on both customer satisfaction and customer loyalty with covariate price. Here we are considering customer satisfaction and customer loyalty together. So when we are considering price as a covariate, it is significant as p values are less than 0.05. But if we remove the covariate price and run one-way MANCOVA, the significant value of multivariate tests like Pillai trace, Wills lambda, which are the most appropriate tests of income category on both customer satisfaction and customer loyalty, is greater than 0.05, which is insignificant. So there is no significant difference of income category on both customer satisfaction and customer loyalty if we do not control the covariate price. So if we are not controlling price, then income category is insignificant with customer satisfaction and customer loyalty. But if we are controlling the covariate price, then there is a significant effect of income category on both customer satisfaction and customer loyalty. So in this way we can write the output of one-way MANCOVA. That's it for one-way MANCOVA.